Hello and welcome to today's session. So today we will going to discuss on the ideal op-amp characteristics and its few of the applications. So probably we will talk about the analysis of inverting amplifier circuit. So let us look into our ideal op-amp characteristics. So an ideal op-amp should have an infinite voltage gain. It should have an infinite input resistance, zero output resistance, zero input offset voltage, zero input offset current, infinite bandwidth, infinite CMRR, infinite sleeve rate, and zero SVRR. So few of these parameters we had discussed in the previous tutorial. You can please watch the previous tutorial to find the explanation for the op-amp parameters. And before to that, in the another tutorial we had discussed about the equivalent circuits of op-amp. So from this equivalent circuit you can see that the op-amp has an infinite resistance and a zero resistance at the output, infinite input resistance, zero output resistance, and an open loop voltage gain is of infinity. So now we will talk about the applications of op-amp. As we have told in the introductory video that op-amp are basically used for mathematical operations. So we will use these circuits to combine the signals, maybe to add it, to subtract it, or to integrate it. So based on the applications, we are going to use this op-amp in various applications. So in that, the first one is the inverting amplifier, means we are applying the input across an inverting terminal and we see that the input is get amplified at the output. Second is a non-inverting amplifier, then voltage follower, then adder and subtractor circuits, integrator, differentiator, and source converter. So now let us take the first one. We'll talk about the inverting amplifier case. Let us analyze this inverting amplifier circuit. So if you see the circuit of an inverting amplifier, then it is connected through a resistance here. So let me complete the circuit first. Or let me connect this and AC source. So an voltage source is connected across an inverting terminal. So this voltage source, let us call this as Vs, through a resistance R1, and the current flowing through this, let us call this as Is, and here the current flowing at this point, let us call this as If. Here there are two resistance. So R1 is a resistance which is connecting a input voltage or input source to a V1 terminal, that is a inverting terminal, and we have one more resistance. This is called as a feedback resistor, where the output voltage is fed back to the input at the inverting terminal. So before analyzing the circuit, let us understand the concept of virtual ground reality. So let me save this page and I'll come back to this later. Page 24. So let me take new page to discuss the concept of virtual ground reality. So we know that the output voltage equation is given by V0 is equal to AV of V2 minus V1. So here V0 is the output voltage, is the output voltage of op-amp that we will get. AV is the open loop voltage gain. Vin, we have not written Vin, let me write this. Okay, I'll write that later. So let us write what is this Vin. Vin is something but the difference of the input voltage, then V2 is the voltage at non-inverting terminal with respect to ground. V1 is the voltage at inverting terminal with respect to ground. So V0 is nothing but the output voltage of an op-amp that we have already written. So this equation can also be written as AV into Vn. So Vn is nothing but the difference of V2 minus V1. So difference voltage is nothing but Vn. So now what is this virtual ground concept reality is that we know that ideally the open loop voltage gain, that is AV, is equal to infinity. Now if we rearrange this equation, then we have V2 minus V1 is equal to V0 by AV, so which is nothing but it is V0 by infinity, which is equal to 0. So then this equation will be V2 is equal to V1, or V2 is approximately equal to V1. So this concept is called as virtual ground concept. Let me write here. This concept is called as virtual ground concept. Why this is called as virtual ground concept? Because if we ground one of the terminal or one of the input, then by virtually the another input is also grounded. Why? Because we know that the ideal characteristic of op-amp that it has an infinite input resistance. So due to that infinite input resistance, what happens if we ground one of the terminal, automatically the other terminal is also virtually grounded. So it means both the terminals will have an voltage of 0 volts. So that is what it means. Now let us come back to our previous graph that we had written. So if I bring it here, so let me save this page. So this is page 25. Okay, so let me bring this back here. Circuit. Now if you see, with the help of the virtual ground concept, then since this V2 terminal is grounded, so it means virtually this V1 terminal is also grounded. It means there is no current flowing to terminal V1. So the current flowing to terminal V1 is 0. So from this I can write straight away a Kirchhoff's current law equation, that is 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 equal to IF. So IS is equal to IF. So then by applying the node voltage analysis, so the current IS can be represented in terms of voltage as the difference between the potential, the difference of potential across the two ends of this resistance R1 divided by the resistance R1. So that is given as, that is Vs, that is Vs minus V1 by R1. It is equal to Rf is again nothing but the difference of the potential across the two ends of this Rf resistance. So that is divided by the Rf resistance. So this is given by V1 minus V0 by Rf. We know that with the help of virtual ground concept, since V2 is equal to 0, then V1 is approximately equal to 0. Then what happens to this equation is, so then from this equation we have Vs by R1 is equal to minus V0 by Rf. So if I rearrange this equation, then I'll get a final equation of V0 is equal to minus Rf by R1 into Vs. So this equation you have to remember it. because this is the equation for an inverting amplifier circuit. So what is the output voltage that you will get? So that depends on now minus RF by R1. So in this entire analysis, we have nowhere come across the terminal or the term, not terminal, sorry. We have not come across the term AV or the open loop voltage gain. So it means this circuit does not depend on the open loop voltage gain. It depends purely on it is RF by R1. So this RF by R1, if we compare this with the output voltage equation, so then that represents the gain, but it is not the open loop gain, it is called as closed loop gain. So if I let me save this, and if I take the new page, then we know that this is equal to AV into Vin. This is our normal equation. So here AV stands for open loop gain into multiplied by Vin. But with our inverting amplifier case, we got this is equal to minus RF, V0 is equal to minus RF by R1 into Vs. So now you can resemble Vs is nothing but your Vn, and AV here it is not the closed loop gain, it is not the open loop gain, it is a closed loop gain. So RF by R1, so this is represented as the another term. Rather than relating this straight away to AV, we'll use another term AF. So AF is equal to RF by R1. So minus sign is nothing but it represents that the output is 180 degree out of phase with the input. That is what it means. So otherwise it has nothing to do with the minus sign. Okay. So this is nothing but our V0 by Vs. We can relate this equation like this. So closed loop gain, let me revise again. The closed loop voltage gain AF of inverting amplifier is independent of open loop gain AV of an op-amp. So the output of this output voltage is negative of the input because it represents the inverted output. Okay. So let us take a simple example here. Let me clear this. Let us take a simple example of a circuit and let us try to analyze it. So just hold on till I complete the circuit. So this is our V2 terminal, this is our V1 terminal, this is minus and this is plus. And let us call this as R1. So need not to be always every time it is called by say RS or something. We can also call this the resistance between the source voltage and V1. We call this as R1 also. So let us call this voltage, this resistance is 470 ohms and this is 4.7 kilo ohms, and the Vs is not given here. So here the question is to calculate the AV. So and Rin. So AV is nothing but here in this case it is AF. So it's a straight away simple formula. So we know that it is AF is equal to minus RF by R1 or RS. So RS is nothing but here it is R1, so it is minus RF by R1. So you just substitute all the values here, RF and R1. So this we will get somewhere around minus 10. So there is no unit for the gain. So remember that. So gain is just minus 10. So this example can be further expanded. For example, if I consider this voltage is 2 volts peak to peak, then we can calculate what is the output voltage. So I'll leave that to you to calculate. So you please calculate what is output voltage V0. So use our equation, that is minus Rf by R1 into Vs. So straight away simple substitution in the formula. So you calculate it, I'll leave it to you. So I'll go for one more example here. So let me save this page as 26, then new page. So let us take an example here. So whenever it is asked to write an inverting amplifier circuit, so in the examination always it may not be given the circuit, so you have to understand. So they just give the parameters. For example, here the question is RF value is given. RF is equal to 100 kilo ohms, R1 is equal to 10 kilo ohms, and Vs is equal to 1 volts. So here question is asked to find closed loop. Let me put this. So it is to find the closed loop gain, that is nothing but AF. Second, it is asked to find the output voltage, that is V0. Next, third, it is asked to find the input current IS. Then fourth, feedback current IF. Okay, so these are the parameters we have to find. That's it. So circuit will not be given. So always remember that whenever we talk about the inverting amplifier case, so circuit remains to be constant. There is no change in the circuit. So you first write the circuit. So circuit looks like this. You have a resistance RS or R1, whatever you want to call, you can call it. So, and you have a feedback resistor which is connected from output to an inverting terminal. Then the non-inverting terminal is grounded, or non-inverting input is grounded. So here you have your Vs, this is your R1, this is your Rf, this is your V0. So first you have to write the circuit like this, then you can start the analysis. So first it is asked to find the AF, so we can straight away calculate this. This is equal to, we know the formula, it is minus Rf by R1. So substitute the values. It is 10 kilo, sorry, it is 100 kilo by 10 kilo, so you will get this as minus 10. Remember, there is no unit for gain, so adjust the value, it is minus 10. So next we have to calculate the output voltage. So output voltage is given by V0 is equal to minus Rf by R1 into Vs. This we can also write this as AF into Vs. So AF we already calculated, it is minus 10. So minus 10 into 1 volt. So then you will get an output of minus 10 volts. It means we are applying here a, say, a sinusoidal voltage of, say, peak to peak of 1 volts. Then we are getting an output voltage of minus 10 volts peak to peak, minus 10 volts peak to peak, so which is 180 degree out of phase. So that is why this minus symbol represents. So let me save this and go to the next page. So what else it is asked to calculate? So third one, it is asked to calculate the input current, so IS. So input current is nothing but the IS. So IS is nothing but, here it is the, we have to apply the voltage analysis circuit. So it is the voltage between the resistance, across the resistance R1. So that is defined as, that is Vs minus V1 by Rs. Rs is nothing but R1 in this case. So V1, we know that it is virtually grounded, so ultimately we have just Vs by Rs. So remember, again and again I'm telling, Rs is nothing but, Rs is equal to R1. So substitute the values. So it is 1 by 10 kilo ohms. So then we will get a current of 0.1 milliamperes. I request you to cross check the calculations. I do not have the calculator right now, so I hope these values which I'm writing here as a result is might be correct, or you can cross check it. And it is asked to find the fourth one, the feedback current. We know that from the analysis, that is 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 equal to IF, so it means the feedback current is also of 0.1 milliamperes. So hope we have we have completed, or we have find all the values which is given in the question. So I hope that you have understood the inverting amplifier analysis and how to solve the example. So thank you for watching the video. We will catch up in the next video, where we will be talking on the non-inverting amplifier analysis and with the suitable example. Thank you so much.